Okay, we are going to continue with this with the previous model, the previous video, and then we are going to continue with the modeling groundwater flow using, of course, data, real data. Okay, now please don't forget to save your model. Okay, save your model. In this case, I'm gonna uh, save in this model 4. Okay, and try to uh, give the name model 4, for example. Okay, model 4. Okay, don't forget about that. Okay, and the next, please, okay, save. Okay, save. Now you have your, okay, you have your name with your model, and then we are going to continue. Now you can continue with, we are going to continue with the modeling. Okay, and then you can see, for example, your elevations. You active, for example, you go to objects and then show, for example, go to here, for example, the area, new and user define, import surface, for example. Okay, if you want to select this, for example, you go to change it, for example, the close to this, and then change the here data visualization, for example. Okay, you want to go to see your grid, for example. Okay, you want to see your grid, like let me see. We don't have a user defined. You want to see here, you can change it, for example, your your colors, etc. Okay, but now the most important thing is to go to once again here in data in object, and then go to here, and then I don't need to now. That's one. Okay. Now you have, for example, for your surface, okay, your model, okay. You have your elevations, for example, okay. Um, okay, we are gonna once again disactivate this. We don't need to now, and then apply. No one apply. Okay, and then now, on the next step is, for example, we are going to here we are going to use the model here, model, go to model, and then overflow times. We are going to use days because our data is in days. Okay, days. This is a steady flow. We can use -10 because this is a steady flow, no problem. Okay, and here, okay, and then after that we are going to uh, set up the, for example, uh, the groundwater. Okay, I'm sorry, the hydraulic conductivity, for example. But first, we need to set up our boundary conditions. Okay, model, go to model, MoFlow package, for example, and go to MoFlow package, and then go to. Actually, we are gonna use. Yeah, that's okay. MoFlow. We are using close once again, and we are using MoFlow 6. Okay, you can use MoFlow 2005. Okay, model once again, MoFlow package and programs. I'm going to, for example, here boundary conditions, and we are going to select. Uh, and let me see here. Um, we are going to select a well package. We're going to select the river package. Let me see here. Where is the river package? And then we are going to select the general boundary condition. Okay, general head in this case. Okay, this one we use in class. Do you remember general head boundary package? Okay, we explained in class how about this boundary. Okay, even the formula in the lecture we reviewed this formula. Okay, and then the well package, the general head boundary, and the river package. Okay, okay, that one we need to for model for this example. Okay, clicking in OK, over OK. Let me see here. Okay, that's fine. Okay, okay. And then the next step is we are gonna add, for example, our we are gonna add the uh, here we are gonna add the hydraulic conductivity, for example, because we have the boundaries now, but first we need to add the, we have the boundary, we select the boundary, but we don't have now the boundary, okay? And then the next step is to add, in this case, our boundaries here, okay? In this case, we are gonna add, for example, this one first. Go to here, for example, file, import your boundary. We have here shape, surface, and shape, the shape. In shape, and then go to inputs, and then after that go to, uh, uh, let me see, we're doing, okay, go to model and go to inputs, and after that go to shapes, okay, and select this one, general, this one, GHB, and click, okay, open, and then intersect, use this one, select set value by, uh, I think it's here by interpolation, okay, and then we need to here to have true. Let me please, 1 minute, please, 1 minute, okay? Okay, and then we are gonna go to here, for example, to, um, okay, if you wanna, for example, this boundary, and we can put here, and then after that we are gonna set up this boundary, okay? Because we have the boundary, let me uh, see here to choose the correct boundary in this case, okay? That one is, and we have this, um, that one is, we are gonna select here, for example, not total, because not total, and then we are gonna have our boundary, for example, here, our model top, for example, let me see here, model top, where is the model top here? Wire layer definition, minus, for example, 10 meters, okay? 10 meters, okay? From model top minus 10 meters is gonna be the boundary, in this case, this boundary that we are gonna add it, for example, okay? And okay, and then after that we can here to see, for example, uh, okay, I think it's okay. It's okay. Um, Let me see once again if we are correct here. Yep, that one is okay. And then we can, for example, for the first boundary, because in class we provide this one using, in this case, the uh, uh, using the using values, right? We put the values in this case, okay? Um, okay, let me see here, and then we are gonna now set the values, intersect cells, okay? And minus 10, okay, let's see. Okay, you are gonna see here your boundary conditions here. Let me see, click, we are gonna change the colors here. For example, we are gonna put this, and then after that, and we are gonna see, we are going to see this one, okay? Okay, let me see once again. Uh, that one is our boundary conditions. Um, okay, that one we can, okay, and then you see the boundary conditions, okay? The boundary condition in this case. You got it? And then we can select, for example, now, let me see if you go to, yes, and after that, we can go to set up or here, for example, okay? In our boundary conditions, and then you see here, double click, and then, sorry, here, that one is the area. You see here these boundary conditions, and then we are going to set up, let me see once again, okay, because we are here, okay, click over this boundary condition, and then we are going to set up here, select this GHB, general condition, okay, the general head boundary condition, okay, and then look, select -1 to 0, and then here we are going to put, here we exactly we use, we are going to use from the model top -5, for example, okay, it's going to start the boundary condition in this case, okay, and then click here, model top -5 meters, for example, and then that's it. And then here I multiply here, that one is the conductance, and then we are going to use, that one is per day, right? If we are using, for example, let me see, I'm going to multiply, for example, that one is, this is high, and then we can put 300, for example, 3,500, because that one we need to calculate, right? If we are considered, for example, for this boundary condition, and then I explain in class how we can calculate this one, is the width times the hydraulic conductivity over the length, okay? Remember, the width times the hydraulic conductivity. For example, let me multiply this one, 0.008 times 100. Yes, between, yeah, that one is times, yeah, 0.08 times, yeah, more or less. Okay, we can adjust this value, don't worry about this, okay? But we can, of course, use here direct. Here, we are going to use direct, okay? Direct, and that one is, of course, for the whole, for the time step, okay? And okay, and then after that, we are gonna, of course, to we don't have, you see here, and then go to data, you are gonna see, for example, the hydraulic conductivity here, and then it's equal to 0.01. Okay, we need to set up this value, okay, using, of course, our data, okay. And the second boundary, and then we are gonna use is the river, okay. And then you see here, for example, this boundary is the same for the enter here, the river, okay. We are gonna import the river. Go to import, and then here the shape, okay, and then go to select this one, river, okay, select the river, and then that one is set up here, it's separate objects, and then for the river, we are going to use here for um, let me see, to here will be, we are going to use this one, okay? And then we are going to use select to this, select values intersect cells, and then after that separate object, that one will be true, and don't worry about this is for default, visible but not selected, and then select for the number of z formulas or the z coordinate and use 1, and then click and edit, and then after that go model top or minus here, we are going to use the river, is going to be more or less from the top minus 0.50 centimeters, 0.5 meters, okay? And that one will be from the top, we are going to have the river below to 0.5 meters, okay? And then after that, yeah, that one will be okay. And okay, we are ready to go to here, okay? Okay, okay, now we are gonna change the color of our river, for example, here, our river, here the color, we are gonna use this, for example, or this color, for example, okay? close, and then you have your river here, okay? And let me show you. That one is your river, okay? Your river. According to you remember here, we have our river here. That one is the river that we are modeling in, of course, in to show the interaction between between the groundwater, of course, and the river. Okay, but remember, in this case, we are using the river package. The river package, we are going to analyze the interaction between groundwater and the surface water between the river, but doesn't simulate, this package doesn't simulate the the streams or the flows in the river. Okay, for that we need to go to here, for example, MoFlow package, and then you go to here, boundary conditions. There are other, like for example, here is this one. That one is a stream flow routing, okay, to model the routing flow, for example, in the river. Okay, okay, and we are using only the river package in this case. And then now you have your river, and then click over your river, and then we are going to set up some data here. Okay, you are in your river. Of course, go to here, and let me see here. Go to your data here, your data MoFlow, and then select MoFlow features, and then select the river. Select the river, and then after that select the period from 0, -1 to 0, and then here you select, for example, for river, we can select, for example, the conduct, like the same, right? That the boundary condition, the river stage is going to be, for example, in this case, we are going to here select the model top -0.5, for example, okay? And then close, okay? And then that one is the state. I'm going to explain you this one. This one is, try to imagine that you have the top, and the stage will be -0.5 meters, okay? And the conductance, we are going to use the same like the boundary conditions. And for our case, in the model top here, because you have another value here. After that, you can change it, this one, according to, of course, your area, of course. And then the river bottom, and then we are going to have here, try to imagine that we have the model here, the model top minus, for example, 1.5. What is the meaning? What is the stage of the clicking OK? And then the stage will be 1 meters, okay, for that one will be the stage for the river, because you have the model, the river stage here starting 0.5 from the top -0.5 until 1.5 meters, okay? And then the difference will be the stage, in this case will be 1, okay? Okay, that's it. We are going to use here calculated, here direct, for the same for the conductance, and then okay, after that, okay. Okay, then we have the rivers now with the information for this river, okay? Okay, we need to, the wells, okay? We need to set up the wells, but first we need to add the hydraulic conductivity data, okay? And then now we can go to File and then import. In this case, you are going to import our surface grid file. Click here and then go to Raster, Rasters, and then select K-grid. Here, this data has this raster has the all information, the hydraulic conductivity in different regions. And here, different regions. Okay, that data coming from the pumping wells, of course, the pumping test, of course. Okay, and specific wells. Okay, select that one here, and then open, and then you are going to see here, and using set up this one, set up values, and then by interpolation, and then here using the triangle interpolation. Okay, an average point in cells, and that's it. Okay, and then if you go to see here now, and then go to or see, for example, your hydraulic conductivity, require here hydrology K, and then apply. Only you are going to see the value of the default by default, okay? The 0.0 you see in the bottom, 0.001 meters, okay? That one is not correct. And then we are going to now, once again to select this one, no one, and then apply. And then we are going to set up now the hydraulic conductivity. Okay, go to grid, go to data, and then after that, edit the data, okay, edit data set, and then go to hydrology, K, and then here delete this value, and then edit the formula, and then go to user defined information here, select here this K, and the raster, double click, and then OK, and apply. Okay. Wait a minute, once again. And then here, okay, that's fine. Okay. Apply, and then close. And then now, and then if we go to here to see our hydraulic conductivity here, okay, for example, and then apply, you are going to see, for example, the different regions. Okay, you move in this case, to see the hydraulic. Look at the bottom. In the bottom, we have the value. Okay, that one is very small values. I hear because we have for this specific study, we need to multiply our data here. Go to data edit, okay, and then multiply this value by 10. Okay, by 10. Okay, like to convert to. Okay, close, and then once again import to your data, and then apply, and then you are going to see immediately the changes. Okay, and then this is nice. Okay, look for the layer, how it's going to change it. For example, your in 3D, for example, here in the bottom, and the right bottom here, look in 3D, your model now. Okay, this is nice. And then here the lateral, and of course, and then here your layer here, this is nice. Okay, and then you have the value of the hydraulic conductivity, in this case 245 meters per day, etc. The difference for different regions of course. Okay, okay, you got it now. Okay, now we are gonna simulate, and then after that we are gonna see the wells. Okay, to compare the changes. Okay, that one, this system doesn't have in this moment the wells. After that we are gonna put the wells. Okay. 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 Let me see now. Okay, we can now run the model. I think everything is okay. The boundary condition, the data, hydraulic conductivity, and then everything is okay. Okay, run the model here. I expect to model 4, and then save. Okay, wonderful. The model runs well, okay? And then we are going to see the balance, of course. And then here, the balance, everything is okay. And then we have the percentage. This one is 0. And then we have by the river, we have inputs from the rivers, okay? For the general head boundary, of course. And outputs, I have in the river outputs, of course, that you see. And then, of course, by the general outputs, this one is coming from the other general condition, of course, okay? That one is the balance, is okay. And then we are going to close here. And then we are going to see, we are going to import the results here. Import your results, open, and then to open, okay. And then now, and then go to here, to data visualization, click to see your, I'm gonna actually contour values here, and then to see the head, for example, and then to each one, for example, you can contour interval, put each one, okay, and then apply. Okay, that one is now, according that one is the groundwater levels or the contour levels, okay, for this system without wells, okay, with the wells. Okay, that one is a real example actually. I'm gonna, of course, I'm gonna give you the all information, the the shapes and the rasters, and then the all information, the data set that you need to develop this example. Okay, and the next step is uh, to uh, uh, to add the wells. Okay, and then now we are going to select this, the grids apply, and then you're going to see this one. Okay, and then now, of course, once again, and then unselect the contours, and then apply. We are going to see only that. Okay, and then for the next step, it's we are going to add the wells. Okay, we have many wells here, and then you need to use this procedure for example, for your project. Okay, and then file, go to file here, and then import, and then go to shapefiles, and then after that in inputs, go to shapes, and then select to, I don't have here the words, actually channels, agricultures, and river observation head. Here is the wells, okay? And then, of course, and we wanna the wells, and then open here. You're gonna see here, and then try to select only set values of intersect cells. Don't use this one. Don't use this one. Set of the cell by interpolation. No. And then here true, and then visible import. Yeah, visible, but no. Select here, and then select one. And here you need to be careful here because, for example, you need to provide some model top here because you need to provide the depth. Okay. Of course, I'm going to put here minus the depth, for example. Depth, for example. Okay. Here, the depth. But you need to create, of course, your depth, and then after that, you can select, or you assume, or you can assume, for example, the for each well, for example, need to change these values. Okay, it's very important. It's very important because you know you are going to have other values. Okay, okay, other information or problem with your model. Okay, we are going to put here. Okay, was error operator because there is undefined. We need to define, of course, this. But in this case, we wanna, for example, put yeah, we wanna put some, for example, let me see. Wait a minute, how we can do that to set up the wells. Okay. Let me see. Maybe we can assume something like, for example, uh, I'm gonna here assume, for example, here minus model tip minus model. Sorry, that one is a model tip model top minus, for example, 10 meters, 9.8 meters, for example. Okay, 9.8. Okay. Yeah, we can do that, for example. Okay, after that we can change. Okay, okay, and then after that we can do. Okay, that one is okay. Okay, clicking OK. Let me see. Clicking OK, and then after that we need to select, for example, the wells here, and then go to ModelMuse features. You need to select the boundary condition well package, and then after that the period from -1 to 0, and then here we are gonna select direct, for example, and then here we can, of course, to use for each well, and Yeah, and then what will be minus, right? Minus, for example, uh, we can use minus 0. And this is per day actually, and this is per day because the wells there doesn't have I think it's the depth is no. uh, That one is we need to figure out how we can put for each one. Okay. For example, in this case, we are gonna use pumping rate in cubic meters per day, and then we here, for example, if we use uh, in general 5 liters or 1 liter per second, for example, per day will be one. Um, let me see. Okay. Uh, okay. That will be 1 liter per second. Will be one. Okay. Times. Okay, we can put, for example, minus 85 cubic meters per second, for example. We are going to see the difference. So minus 1 is 1, for example. Okay, we have many places for this to see the how we can improve that. Okay, um, that one is, for example, we can add it, for example, minus 10, minus 1 liter per second. This we are going to see the behavior of the okay. Okay, and then that's it. If you see here, click in other wells, you are going to verify all wells has the same, right? Then and the same depth. You need to verify after that, and then to you for your project, for example, and then to change it for each well, for example, try to change the 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 in this case that your C coordinate and change the amount of the water that you are going to extract in this case, okay? And then close, and then after that, please here, and then you have your wells, and then now you can run the model once again, okay? Run the model here, and then let me see. I think everything is okay here. Let me verify the here some boundaries. For example, this one I think is okay. I think it's okay. Um, okay, and yeah, okay. And let me see here. Okay, let me see. There was okay. Once again, we are gonna run the model. Okay, run the model here, and then yes. Okay, close. Uh, okay, you are gonna see the balance here. Try to see the balance, and then now you are gonna have your wells, right? Inputs, and then we have a little, yeah, we need to set up something because by out we have output. We didn't put negative. Okay, okay, that one is the out. By input we have, yeah, we have, for example, that one is the from coming from the wells. Okay, okay, close this one, and then enter, and let me review once again. Features. Okay, let me see what's happening here. Let me see. Here we're gonna see the wells. Okay, features, I need to make sure. Okay, minus. And then another thing is in properties, okay? Make sure in data set, please here, and then you need to activate your hydraulic conductivity, K and Y. Don't forget about that. And then that's it. Oh, no, oh yeah, because you have this one, don't worry about this. Okay, yeah. And once again, run the model. Okay, okay. close this. And then once again, we're going to see the balance here. Okay, the balance here, we don't have inputs by wells. We have outputs at the river, general head boundary, and outputs, we have outputs by the wells and by the river, of course, okay? Okay, and then close to this, and then here, close, let me see, close, and then after that, import your results, okay? You know now how you can import the results. Okay, it's fine. And then we are going to see this. This is a little bit different, right? That one is for the constant. We put constants extractions, but to modify for your project, you need to set up for each well, what is the amount of the water that you are going to extract or you are going to use, okay? And then go to here, and then to see the contours, and then go to here, and then separate by one, apply. And now color grids, we are going to deactivate this one, and then now, okay? Then you have now your model, okay? Your model, okay? Oh, actually, we need to extract more water because the water that we set up in the wells is very small, okay? Okay, thank you so much. I appreciate your attention, and then try to practice this example, this real example, using the data wells and the river, actually, okay? Once again, look for the river, okay? And then you can set up, of course, manually here, the river using, for example, that one, this option, for example, polylines. Using polylines, you can set up, for example, the river, or using using polylines, actually. Okay, thank you so much. Bye bye. See you in the next video.